Hey guys, the objective for this video is to define an equation for settlement. We're then going to be using that equation, and you'll see that we're going to have to find the change in void ratio, which we developed in the previous videos, and then we're going to find the final settlement for an example we're going to do. Okay, so settlement is defined as minus the change of void ratios times by h, which is the layer thickness we're looking at, over 1 plus the initial void ratio. Okay, so I'll define these on the side. Change in E is the change in void ratio. H is the layer thickness. And E subscript I is the initial void ratio. Okay, so let's do an example. So we have a layer of soil which is 3 meters. Okay, let's say for this soil the initial void ratio was 1.1. The OCR, the over consolidation ratio, is 1.3. The C subscript C is 0.3. The C subscript R is 0.05. And let's say that we're getting a stress increase of 60 to 70 kPa. Okay, now this stress increase could be caused by several things. For example, we could be coming and putting a structure on this soil layer, which would cause settlement, right? Which would cause a vertical stress increase in our layer. We could be putting gravel, or there could be deposition of other materials on top, causing a stress increase. Okay, so we're getting a stress increase for some reason. Now, as you can see, based on our settlement, and the aim is to find the settlement of this layer based on all these properties. Now, you can see that we know H straight away is 3 meters, is the layer thickness, and we have EI. So all we need is this change in E, which is the change in void ratio. Okay, so we're going to be using the stuff we developed in the previous videos, where we go from change in vertical stress, effective stress, to the change in void ratio, right? So the thing we always need to know first is, what are we dealing with? Are we dealing with an over-consolidated? Are we dealing with normally consolidated? Are we dealing with a combination of both? And the way we work that out is by finding the pre-consolidated stress, okay? So we know the OCR equals the pre-consolidated stress over the initial stress, which means we can find the pre-consolidated stress. OCR is 1.3. The initial stress is 60. So we get a value of 1.3 by 60 of 78. Okay, so you can see that our pre-consolidated stress is larger than our final effective stress of 70. Okay, which means that we have a over-consolidated sample, right? That's the sample we're dealing with. It's overly consolidated. So, and if you want to remember, I just brought another piece of paper. We had our graph, okay, which looked like something like this. Okay. So we are here, sigma PC. For our case, sigma final is here and sigma initial is there, okay? And this branch was the over-consolidated branch. Okay, so the only reason we need to know what that is so we can find our change in void ratio. So if I were to draw a nice diagram of what's going on, okay, we're going from 60 to 70. So here is sigma I, which is 60 kPa, sigma final, and these are all effective. Sigma final, which is 70, and we know that our pre-consolidated is down here at 78. Okay, so what does this tell us? This tells us that because this is a over-consolidated sample, we know to use CR. Okay, so we've been given CR is 0.3, so we can go ahead and work out the. So we have EI and EF. So we know the formula EF equals minus CR log sigma F dash on sigma I dash plus EI, which means that if we pop the EI to this side, we have EF minus EI, which is the change in the void ratio, equals minus CR log sigma F dash on sigma I dash. Okay, which we can calculate. Because CR we know is 0.05, so minus 0.05 log of the final is 70 over the initial is 60. So 70 over 60, if we work this out, So log 70 divides 60 times minus 0.05. We get minus 0.0033. Okay, we can then go ahead and plug this value into our formula for the settlement. We know settlement is this formula up here, so we can find that settlement equals minus change E outside of H on 1 plus the initial void ratio. Okay, we just found change in E of minus 0.0033. Okay, so this is minus 0.0033. Okay, times by H, our layer thickness we know is 3 meters. So this is 3 over 1 plus the void ratio, the initial void ratio, and we have an initial void ratio of 1.1. So plus 1.1, and if we go ahead and calculate this, so minus minus gives us a positive 0.033 times by 3 divided by 2.1. So we get 0.0047 meters, which is the same as 4.7 millimeters. Okay, so that is how you find the settlement in a layer of soil. In the next video, which I highly recommend you watch, we will not be given the stress increase. We're going to have to go ahead and actually calculate the effective stress increase. Okay, so it's going to be a little bit more complex. The procedure is the same. The procedure is you go and find the change in E, so you can find the settlement, but we're not going to be given the stress increase. We're going to have to find that using the effective stress principles we developed 3 or 4 series ago. Okay, so I recommend you check out the next video. Hope that helps, guys.